is 113. Let's first talk about the topology on WR over P. So this is not as you thought, it just something's start from the topology here as product topology, just from Rn, and then go from here formally to get topology on WR invert P. Actually, it's not, as we remarked. So from ZP you have p-adic topology. Of course, you could induce topology here. The p-adic topology. But here a problem is this is not open in WR. Remark. Like KV p-adic field. Use residue field. Small k. And let R to be the functor applying as euro k bar quotient might be. It's the same as OCK quotient might be. So introduce p-adic, or introduce a topological ring structure. WR invert P. This is what I call weak topology in the last video, but that's not very precise actually. Let's be more precise on WR. Yeah, we have the weak topology. That's the product topology. We have the product topology. Oh, and you could also describe this topology by saying that opens are given by this, because actually the product topology should be what? Should be so some opens on each product factor, but infinitely many product factor as the whole ring. So this is just corresponds to a product with A and the product with R. This is for the first n terms. Do you see this is describing the opens of the product ring. Here A is some idea of R. let's say open ID of R. Okay, yeah, which means this is open of R. Okay, so this is what we describe. So those opens could be given by valuation ball, right? The ball is given by the matrix that comes from the valuation. Okay, so we're going to describe a topological ring structure on WR invert P that induces the natural p-adic product topology on the subring it should coincide with this product topology we described. And extends it to natural topological ring structure B-drum plus and whose induced quotient topology on the residue field CK is the natural valuation topology. That's what we want to do. So I'm going to just list some of the remarks without really giving the proof of that. So just refer to the lecture notes, exercise 4.5.3. So roughly speaking, for this ring, the idea is to impose topology using controlled decay of coefficients of Laurent series in P. Remark. Let's call this remark 1, and then 1.1. The situation is different from topologizing QP from the topology of ZP. So there's, how do we define the open? The open is just given by given by this. Right, this forms open of X in Q. And as we remarked, this is not open in WR. In contrast, the PZP is open in ZP. When this R is given, we add valuation topology. Compared to discrete topology. So let's just mention some results without really prove it. So to do that, there are several steps. Actually, we are going to define open as follows for any open ideals, which means open submodules of R, say open ideals of R, and for any positive integer, we are going to define submodule called UNA to be uni j bigger than minus n, p minus j times w, this power of this ideal, plus then p-adic, and this is submodule of this ring we want to describe its topological structure, where Wj, for a small remark, for ideal J of R means the ideal of with vectors in WR whose components all lie in J. And there are several facts. Actually, U and A is JK stable. WR submodule. Second thing, actually, as I said, this is an extension of weak topology on WR. So the intersection of this open actually prove this is a fact. I'm not proving it here, but let me mention is this, and hence WR endowed with its product topology using p-adic topology. R is a closed topological subring of this WR invert P. Moreover, if we look at K0, W small k residue field containing here, because recall that we have a section makes this possible. Actually, we have projection with this the residue field and a section gives the embedding. And so the topology here, then this WA will be trivial, because K is a field and this ideal is only, open ideal is only 0, and so what you got is only the p-adic topology, which is exactly the topology on K0. Let's close the subfield with its Euro p-adic topology. So small k is discrete subring. Okay, so almost all what I want to mention. Let's come back to actually recall we were proving in exercise 112 following thing. We claim that the K0 algebra B the RAM plus contains a copy of K bar, a unique copy of K bar actually, as a subfield over K0. So actually we have described what is this K0 algebra structure over B RAM plus. For example, you can use this. And this exercise 112 claims more this lifting from the residue field CK to B-RAM plus is compatible with GK0 action. That's what we have proved exercise 112, but we haven't really proved the following thing. Moreover, any extension K prime over K0 inside K bar with finite ramification index gets its valuation topology as the subspace topology induced by the lifting. In particular, K prime will be closed inside VRAM plus if it is complete. And so so the proof of the second part involves the fact we just proved. Actually, this K0 is closed subfield with its Euro p-adic topology. at the subspace. I mean, so the topology, the product topology, sorry, so the natural topology on bit-RAM, so it's open that describing this. Actually, this open, when you look at it, intersection with WR, gives you this. And then this in particular tells you that the subspace topology from bit-RAM plus over K0 is the Euro topology, and we kind of want to show this is the same for whatever K prime over K0 finite ramification index extension. So now pick an algebraic extension K prime over K0 with finite ramification index. Notice the construction or the definition bit-RAM doesn't, I mean, let's say depends on K bar completion rather than depends on K, because by the definition actually what you only use is R as limit of CK, so this is CK quotient P or OCK, okay, and then construct what is WR, and then what is WR inward P, and then what is quotient by kernel power, and then taking your limit, right? So this is it. So which means you could replace your K with any elements inside K bar, and they give you the same, right? Give you the same bit-RAM, and in particular the same topology. So let's see. In particular, if we consider maximum ramified, this is W K bar over P. Then if you just notice the fact that the subspace topology from bit-RAM plus is the validation topology. The p-adic topology. In the Euro one. And so if your question is about this, if your K prime is this, then it's fine. We are done. So this is by our remark above at the beginning. I didn't give a proof, but I mentioned that, right? Remark 1.2. But unfortunately, K prime is not necessarily this, but that's not too bad, because notice this over I mean, this should be is a finite. It's a finite dimensional vector space over K0 ramified. Right. It suffices to show the induced topology or the subspace topology over this is the Euro one or is the expected one. But we can just call this K, and it will give you the same bitogram as the original K. So we replace K by this one. Now notice this is topological K0 algebra and the evaluation topology. And K is its product topology for a fixed K0 basis. I mean, this is K0 vector space. Okay, as Euro, so we have K0, K, QP. This is maximal ramified. This is totally ramified. So if we gave K its valuation topology, and let me mention over K0 again, the topology is the subspace topology is the Euro. It's okay. Then the natural map by the lifting. Yeah, under the lifting is continuous.